Now we are going to discuss spherical mirrors and definitions in connection with the spherical mirrors. Okay, so in the previous video we have discussed introduction of ray optics, reflection of light, and also law of reflection of light. Okay, so today we are going to discuss spherical mirrors and definitions in connection with spherical mirrors. So spherical mirrors, so the diagram explains figure A, a hollow sphere cut by the plane. Figure B represents a concave mirror. Figure C represents a convex mirror. Okay. So figure A, consider a hollow glass sphere being cut by the plane. So the section A, P, B, the points cut by a plane forms a part of a sphere and it is known as a spherical surface. Okay. So that is known as a spherical surface. If either side of the spherical surface is silvered, okay, so if it is silvered at the outer edge, okay, so it is called as a concave mirror. If it is silvered at the inner edge, okay, so that is a convex mirror. Okay, so if either side of the spherical surface is silvered, we get a spherical mirror. A spherical mirror is a reflection surface which forms a part of a hollow sphere. Spherical mirror are of two types, concave mirror and also the convex mirror. So first we are going to discuss a concave mirror. So concave mirror is nothing but a spherical mirror in which outer bulged surface is silvered. Okay, so you can see the second diagram, figure B. Okay, so the outer bulged surface is silver polished and the reflection of light takes place from inner hollow surface. Okay, so the reflection of light takes place from inner hollow surface. Okay, so the laser light indicates the reflection of light takes place from inner hollow surface. It's called as a concave mirror. Okay, and the second one is a convex mirror. So figure C explains the convex mirror, a spherical mirror in which the inner hollow surface is silvered polished. So the laser pointer indicates the inner hollow surface. The inner hollow surface is silvered polished and the reflection of light takes place from the outer bulged surface. Okay, so the reflection of light takes place from the outer bulged surface, so it is called as a convex mirror. Now we are going to discuss some of the definitions in connection with the spherical mirrors. So figure explains the characteristics of a concave mirror. Okay, already we know that. So what is concave mirror? So concave mirror is outer bulged surface is silvery coated. Okay, so the inner surface which is used to reflect the light. Okay, so that is a concave mirror. The inner surface which is used to reflect the light, that is a concave mirror. So in this title we are going to discuss some of the notations we have to use and the characteristics of a concave mirror and also the convex mirror. So that is point P and the point C, point F. So what are the definitions for point P, point F and also point C? So first one is pole. Okay, so the pole which is denoted as a symbol of point P, so it is the middle point of the spherical mirror. So this is a spherical mirror. Okay, so in the spherical mirror, this is the middle point of the spherical mirror. So pole, which is denoted as a symbol of P, so it is the middle point of the spherical mirror. Okay, very clear with that. So the next one term is center of curvature. Center of curvature, which is used to C. So it is the center C of the sphere. Okay, so in this diagram, this is the center C of the sphere, of which the mirror forms a part. Okay, so if you are considering the whole sphere, the center sphere is denoted as a center of curvature. Okay, and the third one is radius of curvature. Radius of curvature, which is denoted as a symbol of R. So it is nothing but the distance between the center to edge. In this diagram, it is noted as AC, otherwise R equal to AC, or otherwise R equal to BC. Okay, so that is the center of curvature. So it is the radius R equal to AC or BC of the sphere, of which the mirror forms a part. Okay, so that is the radius of a curvature. And the next one is principal axis. So the line PC, okay, so the line PC passing through the pole, okay, the point P is a pole, so the line PC passing through the pole and the center of the curvature C, okay, so it is called as the principal axis. The next definition is a linear aperture. So it is the diameter AB, linear aperture, it is the diameter AB of the circular boundary of the spherical mirror, okay. So the diameter AB of the circular boundary of the spherical mirror. And the next one is angular aperture. It is the angle ACB subtended by the boundary of the spherical mirror at its center of curvature C. So it is called as an angular aperture. And the next one definition is principal focus. It is denoted as a letter of F. So in this diagram, it is um, F. Okay, so that is called as a principal focus. So this diagram explains figure A, that is principal focus of a concave mirror. So a narrow beam of light, it is a narrow beam of light parallel to the principal axis, either actually converges to or appears to diverge from a point F on the principal axis after the reflection from this spherical mirror. Okay, so the light is incident on the concave mirror and it is get reflected, okay, and it is converges at a certain point. Okay, so the point is called as a principal focus of the mirror. So this is the real focus. Okay, so the real focus occurred in a concave mirror. Okay, clear? So the second diagram, figure B, principal focus of convex mirror. So it explains the principal focus of a convex mirror. So already we know that the inner surface is silvered coated. Okay, so the outer surface which is used to reflect the beam. Okay, so it is a convex mirror. So a concave mirror has a real focus, already we have discussed, while a convex mirror has a virtual focus. Okay, so the diagram explains the virtual focus. Okay, so when it diverges but appears to converge if rays are extended back. Okay, so a point from which divergent rays, so the point is a virtual focus. Okay, a point from which a divergent rays. Okay, these are all divergent rays. So a point from which divergent rays, that is a virtual focus. Okay, so the next one is focal length, denoted as a symbol of F. Okay, so what is focal length? It is the distance between the F equal to PF. Okay, so the distance between pole and the focus. So that is the focal length. So it is the distance between the focus and the pole of the mirror. So that is denoted as a symbol of a F. Focal plane. So the diagram explains the focal plane of a concave mirror. Okay, so this is a concave mirror. So the vertical plane, so the dotted lines indicates the vertical plane. So the vertical plane passing through the principal focus, okay, passing through the principal focus F and perpendicular to the principal axis. Okay, so the vertical plane is perpendicular to the principal axis. It is called as a focal plane. When a parallel beam of light is incident, okay, on a concave mirror at a small angle to the principal axis, it is converged to a point. Okay, it is converged to the point in the focal plane of the mirror shown in the figure. Okay, clear?